Okay, so a quick question. How many of you guys working as Android developers? I suppose. Okay, so most of you. How many of you love to work with a Gradle, Android Gradle plugin? How many of you feel like it's a total magic? You have no idea what's happening around? Still a lot of hands, which is nice. So I was thinking and sitting about what would be the amalgamation of the Gradle and Android, and thankfully I came up with this image. The name may be not the best, but maybe it suits it. So my topic will focus on the Android Gradle plugins Surface API, and for you just to feel ground why this is important, you first need to understand the business case I'm trying to solve. I'm working on the Disciple Media application. It's a service as a platform solution. You as an influencer or the manager of the community, for example, Android Budapest community, want to pick people in one place, in one web page, one mobile application, submit posts, send messages, engage in live events. Sell premium content is also possible to do through that, and even learning and management platform is embedded within this beast. As you can imagine, with the sheer amount of applications that needs to be published, we have a lot of challenges to configure those, and not all the configurations can be pulled out from the remote, from the API endpoints, especially when you need to disable such things or enable optionally like Facebook SDK, Google Services integration, or enable features for audio streaming or disabling them. Sometimes you need to remove permission or edit. Again, a good example would be Facebook SDK integration, and it comes with a viral permission called add-id, and this forces the clients who take the application that we built for them and publish to the API market. They find it's very surprising that they need to opt into something add-id that they have no idea what it is. So we need to explain them. If they use Facebook SDK, they need to use it. If not, we don't want other clients to be affected. And this is type of the configuration that you cannot simply launch on, launch off. As soon as you publish, you either have it or you don't have it. And the Android Gradle plugin and Gradle overall as ecosystem allow us to build a custom logic during the build logic. Sounds tricky, but I will try to guide you as much as possible through this. So we will start with the project structure setup. Imagine creating a new project. You would have a classic settings Gradle file, application build Gradle file, and those orange part is the one I will focus on. The build logic here is an included build. By included build, I mean that we build the plugin alongside with the application project itself. We don't host it in a separate Git repo. It's useful when you want to avoid building a new artifact over and over, publish it to Maven. And the changes happen pretty frequent because we add remove features to the build logic, and it's become very, very complex with the time. The initial efforts were just throw everything in the build Gradle file, but it's never scaled well. So we came up with a decision just host it inside the Git repo. To enable the build logic, you would put include build in your settings Gradle file. And now you will come up with some identifier your plugin. The plugin system in the Gradle relies on the IDs. Behind it, you will still have to supply the fully qualified path to the plugin. And in order to achieve this goal, you would need to put some code inside the module. Android folder, which is on top of, one moment, let me have it here. So this is just a folder. You can put whatever plugins. We decided to stick to the Android way, Android word, because it would be built on top of the Android Gradle plugin. And the important part, I skip other plugins, but this is the most important, is you need to apply Java Gradle plugin, put on the class path Android tools build, and then you need to identify the manifest for your plugin. Here you will see the plugin ID identifier and the fully qualified path to the class itself. Oops. Then in order for us to hook into the plugin, you would create a class, make it abstract, make it open. This would help reduce the time and efforts for the Gradle actually to hook additional wrappings around it. If you ever notice, the stack trace from Gradle comes with some gibberish suffixes ended in the end of your plugin or whatever plugin. This is happening because Gradle rewraps everything for you and manages types for you. You would need to extend the plugin. You can put in your generic project, which we are doing here because we're interested in developing a plugin for project. You can also develop it for settings, but this is not will be covered. It just mentioned for the sake of understanding that plugins are not limited to projects only. The next step would be to hook into the lifecycle properly. By properly, I mean that we already have extensions available for us to consume, and everything you touch into the in the Gradle is actually done through the extensions. The most frequently used and recognized would be extension for Android that you would see, and then there would be some method called like compile SDK. And this is behind the scene delegated to the app extension instance. There is a convenience method called the, coming from the Kotlin DSL, and it gives you the access to this extension. But for today's talk, we are going to focus actually on kind of newer approach coming from 2020, and this is Android Components extension. It has much longer name. I believe this is all coming from the collision of the names. So why the Android Gradle team came up with the new APIs, mostly due to the fact that they are leaking abstractions from the old plugin source codes. And by leaking, I mean you can really take a look which task is called to package your Android archive, your APK, your manifest, which kind of seems okay from the Gradle perspective, but not okay from the Android Gradle team because they wanted to hide stuff. They might rename those tasks, they might introduce new one. You are not supposed to work with those types directly. And in addition to leaking the abstractions, they started more heavily invest on integrating with the provider and property types. Those are lazy configurations. Those are wrappers or promises for some logic to be executed. And this is very important part whenever you have some logic that performs a network calls, performs some heavy computations. And in our case, we will make a network call before we don't want to put it on the configuration time. So any task you run from your command line, you will notice that it will show configuration, and it will take forever if you won't be careful and use the provider API. So now the meat of the presentation, loading the remote configuration. We will establish the local version of extension. This is a dev community extension, which is important mostly for developers because they would use this extension in order to provide authentication to the plugin, and then the base URL for the optional injection during the testing. Dev community extension now comes up with additional properties and the nested one. This is a config credential shown on the previous screen, and the important piece of knowledge out of this is that please use action as a Gradle API piece because using Kotlin lambdas or Groovy closures, you will get them as while interoperating between Groovy and the Kotlin. In order to register extension, you call project.extensions create, and as you can see here, we put the alias. And in case of Android, it was Android. In case of the new extension, it was Android Components. And this would be, as you can see, we just give a type, and it will be managed by Gradle for us. And then in the code, you can put something like this, optionally enable for the developers to put this dev community Gradle file. We don't want to expose email or password in reality. That's why we put this file behind the git ignore. What developer would put the name of the community that they want to build over. This will make sure that we pull all the necessary resources, all the necessary icons. Of course, this file needs to be behind the git ignore. We shouldn't expose this information, But you might think, how then we can provide this information later? This is coming from either environment variables or the Gradle properties. So the load remote config task itself accepts as a input the config credentials, community, and output some file. And this is another piece which took some time to wrap our head around. Everything you do with the build systems, doesn't matter if it's Gradle or if you do the iOS development, everything behind the scene is just passing one file from one task to another and transforming in some way. So we do the same job here. We pull some data, dump it in the file, and leave the out artifact. Pulling the data, in our case, was done through the retrofit. HTTP client is not important. You can stick to whatever you like. Thus, here you would see us calling the extension functions that just implements over the credentials, the API instance, make a call, make it blocking, which is nice. We are not, we are totally fine to do this within a task. And then we will just simply dump the contents of this response into the file. Beforehand, we need to make sure that the parent folders exist. And later in the presentation, we will use toNative config extension function, which is just a convenience to transform from file to the data class that would be more easier to access and work with. This is a 8 to 11 line of code. So now I will go through multiple use cases. One would be about renaming APK, another would be about renaming bundle, about configuring build config files, manifest placeholders, and the last one would be dedicated about pulling out the custom application icon, splash screens and notification icon. So renaming APK goes together with app ID, version code, version names because they're most of the time tightly coupled. It would be something custom for your case, but we use those to create a unique name that we will later put to S3 bucket, for instance. The steps to perform this action of renaming APK is again making a network call to get the configuration. This is the load remote config task shown on the previous section. Then we will take app ID out of that remote configuration data class. We will take version code and version name either from environment variables or from the Gradle properties. And finally, we will connect those providers to the variant and output types. So variant is a combination of the product flavor and build type. I think I see some people waving their hands, those who don't. It's basically a kind of GUT type object where you can configure it as much as you want to, and its outputs is not something that is supposed to be exposed, but it's still living around. And I believe again it's connected to the fact how the plugin evolved with the time, so they stick to the outputs being the part of the variant. So hooking into variants. First thing first, we grab our application Android component extension. We hook into onVariants callback. This is what comes from the application Android components extension instance. Then we query outputs and find the variant output implementation. Remember me speaking about the things leaking abstractions. This is unfortunately yet another example of leaking abstraction. This is not supposed to happen. Maybe there is a better way. I didn't find the one. But the variant output implementation actually exposes the file name, the provider to the file name. So we will hook our custom provider there. And the Android Gradle Plugin will make sure that it will produce APK renamed to our pattern. Output providers is a custom class. Its main purpose is to be instantiated with necessary providers, and then we pass its configuration to the either output and variant. This will come shortly. So this is the constructor of this output providers class. As you can see, we are able to configure application ID, version name, version code, output file name. But the interesting part would be how those providers coming alive. So project comes with a providers container that you can use to get, again, in the lazy way, access to the Gradle property or environment variable, which is the 5th line of code, version name, or else from provider or else unset if not provided. The same goes to the version code. We follow the same logic here. And on the command line, this is how you would pass those parameters. You would write -p, the key name, and the value. On CI, you can still opt in using version code, version name, and just simply calling the command without those props. So now acquiring the application ID is coming from the API endpoint. Thus, we are flat mapping over load remote config. Load remote config is a task provider. So at this moment of time, we're still in configuration lifecycle. We haven't yet even started executing tasks, but we already make a receipt of what we should do with this load remote configuration. We should grab this task. We should grab its task out artifact, which would be file. And then we would need to map it to something which we can extract property out of. So it's a JSON mapped to the data class. Pretty common job when you're working with any API. But since Android Gradle 1.1, we had a problem of, even though it's promised to be executed at execution time, it was evaluated at the configuration time and breaking the build. And this is what was done by the Android Gradle Plugin Analytics internal plugin. So they collect some kind of analytics, which is not surprising. And this stuff was breaking this custom configuration for us. And unfortunately, the solution, I feel like it's, again, not the best way, but wrap with extra provider. And somehow it's managed to avoid this clash of getting evaluated too early and eventually reaching the execution stage. Now we can see the whole picture coming together. We grab multiple providers, we flat map over them until we get our magic string in the end, which would be the combination of those you can see on the screen. And finally, because we still need to make sure that those properties propagated Android Gradle plugin, we simply set those providers using accessing variant output implementation instance directly. And the same goes in case of the application ID. We need to pass it. If not done, nothing will be built. And it makes sense because application ID is a package name of your published application. Renaming bundle becomes mostly the similar, but because it will rely on, it's a newer, kind of newer way to package stuff. It doesn't require those manipulations of tapping into output variant implementation. You grab the variant, you create your rename bundle task, and that would be kind of the brief. We use the same factory method behind the scenes to instantiate how output file name will look. This what you already seen on the previous section where we were mapping, flat mapping multiple times over version code, version name to get the output file name. And we grab those providers later in order to wire the output file name into the out artifact. So output file, you can see it's on the 7th line, is what we are interested in altering. But the task itself is pretty simple. We just take the incoming bundle and copy it once more. So renaming is not happening at the task execution, but happening during the configuration stage. So first thing first, we need to register the task. There is a, it will just grab the name and attach the suffix. But the new API, which is the important part, is coming through the artifacts, calling artifacts over the variant, and then supplying through the use the path to your task. This way, Android Gradle plugin knows that there is a custom task that needs to be injected into its pipeline and being executed. And then on the line 10, we call wired with files. And the Android Gradle plugin actually provides us the path of both coming file and outcoming file. So we are not interested on how it's managed behind the scene. It's happening for us. And we need to make sure that we request the proper file. And in this case, it's a bundle. And it's a part of the single artifact type. The tricky part now starts here. We reconfigure our rename bundle task the second time. And we make sure that the out artifact, this is the property of our task, we reset its file provider behind the scene by simply grabbing the parent folder where Gradle wanted to put our bundle. Grabbing its parent folder, we create another file, but with the name that we have mapped out of the output file name provider. Remember, output file name provider is backed up by the chain of those 3 previous providers, including the network call. But still, it will be all safe to do this way and won't jam your configuration stage. With build config and manifest placeholder wiring, the approach would be, again, based on the provider APIs. No surprise, because we want to be efficient. The only difference that it's a map property type, which is map on steroids, which allows us simply provide to map our existing providers to the map of, and then put it all into the build config files. Sorry, I'm reiterating it here. But the important line would be the 5th one, where we do version got map, grabbing actually version code and throwing into the build number. This can be used for any other type or feature we can pull out of the API and we want to put in the build config for some reason. Another example, which I didn't include, but you can get from the VCS your current hash and put it in the build config. This would be a way you will map over creating the provider that would be backed up by task that calls a VCS and gives you the value. In case of the manifest placeholders, those purely come from API. We again grab the load remote config task provider, flat map over its output artifact, which is file with JSON, transform this file to the data class and access its properties here, and finally throw everything into the manifest placeholders container. So this part here is what I've started this talk with, is altering the Android manifest file itself. And I would like to show you a use case which is used, which our QA team relies on, is enabling Charles proxy tooling for network call modification, even for the release builds. You shouldn't usually do this, and it's a good idea not to do this for the production apps. But for our case, we have a completely dedicated QA community, so we are comfortable with that. But to enable the proxy settings, you would first need to generate a network config file, and then you need to attach this network config file to the manifest. Another use case for modifying, the reason why would you like to modify Android manifest is adding, removing permissions, adding, removing services. Again, it's connected to the fact that every year Google makes it harder and harder to manage foreground services, so you need to pull more permissions, and it's become a hindrance when you publish application. You need commit into more privacy policies, and privacy policies can be a legal issue. Good when they are not, but you never know. So the less permissions you bring, the better for the client in the end. So general approach for us to modify any manifest file is just to create a task where manifest would be an input file. This input file will be provided by Artifacts API from a variant. We give it a key. We say, give us merged manifest file, and it will give this file for us. We will parse the XML, modify contents of this XML, dump contents to the new output file, and the Gradle will, Android Gradle Plugin will know that this transformation happened, and this is file that it needs to pass forward to the chain. So enabling Charles proxy, again, creating folder XML. In the side date folder, we will create another XML file. Naming here is not important, whatever you like, but it will be important for the later task. We need to link this task to the sources API. This is coming out of the variant. Again, variant, remember, it's a GUT object which you can configure and should configure. This is its purpose. The second task that we will create will actually append this network security config to the application node within your XML file. So again, we extend over application Android components extension. We call into the on variants, we grab the variant, we register a task that again grabs the old remote config file. Remember, the one pulls the JSON, and there we know if the flag is set true or not, if we're interested in enabling proxy. This could be not, this is not mandatory to do this way. You can use Gradle property. So project providers, Gradle property, if you need from command line to enable this. Then we create a AndroidManifest config task, which actually depends on the Gen network security config. And another important takeoff, if you ever try to create a task, you will probably saw something called depends on or finalized by. This is how you can manually configure which task go first and which follows it. You don't need to do this. As soon as you're using task provider, the dependency will be pulled in, and the Gradle will complete a task for building this graph of tasks for you, and you don't need to care about that. Simply make sure that you use task provider and flat map over it. So the flat map and map is an answer in most of the cases. So Gen network security config exposes an additional handy function called network config. The important takeoff here, the seventh line, when we generate resources, we are actually generating the directory, and that's why we use directory property, not a regular file property. And again, property is a promise of something happening in the future. So we have no idea the configuration time, what will end up there. Append manifest config task will grab the network config regular file property, read its name, and will put it in the XML after that. Here is the steps of the task action of the append manifest config task. We will acquire the reference to the manifest file. So this is happening already at execution time. So it's totally fine to resolve the provider by calling the get function. Then the file actually already coming from the Android Gradle plugin. You are not interested from which folder it's coming. So if you ever open the build folder, you saw there is a myriads of folders there, myriads files. You shouldn't tap there trying to remember where those files are lying around. This is implementation today, and it should be hidden. That's why it's really important to make sure that you rely on the Android Gradle plugin to give you access to those files. And now we are building the 3 out of these files contents. This is the Gradle.xml parser tool. We are looking for the application node. We are looking for its property called Android Network Security Config, and on the line 18, we're setting the reference to this property. Line 21, 23 simply dumps the contents of modified XML into your output file. Now, the downloading of app icons. In this use case, I would like to point attention on the worker executor API. If you notice, whenever you run the Gradle task, it usually spans a lot of workers around it, and it's most of the time matches the number of processors you have. And then the task is distributed around those. You get this parallelization of your task execution. But sometimes one task can be faster, another would be slower, but in the end they will be all forced into one timeline pipeline, and there would be places of idle time where we can push an inner working of one task or unit of work into other worker threads. We rely on the Cloudinary service. It's not that much important which service you use, just for you to understand what Cloudinary means. We construct the links to follow the predefined specifications. We still use drawable HDPI and not MIP-map format, so those would be PNG files. We create a work action passing their URL to this file, and we're making HTTP connection, dump contents again to the file system, and connect sources API to the variant object. Again, if you don't do that, the Gradle will have no idea, Android Gradle plugin will have no idea that you generated something. So once more, we create a task, we register it, We grab the remote configuration, and here is the linking part happening. So variant have a sources that has res. It also has assets. You can also generate assets if there is a need. It's good. It's all indexed, so you can see whatever is inside by opening in Android Studio. On the 9th line, we provide the reference to the task provider. It's actually not a task, but task provider, so it's still lazy. And then we tell which folder will be actually generated and which needs to be included in your APK or bundle in the end. Here goes a configuration part of the action itself. So we grab native config file on the first line, grab Cloudinary URL, and then we make sure that we download notification, header, logger, launch screen, icon launcher. Behind the scene is just a configuration that gives us a map of key value, and then the two part will be resolved in the URL in the end. It's just a specification that for this screen, for this density, we need this type of an icon. And downloading, the interesting part itself happening first by us acquiring the worker executor and launching it in no isolation mode. Whatever you need to know about no isolation is the fastest, the default one. If you need more strict isolation, usually it means that you have some weird cases when you have to run those workers in different GVMs or different environment required, or even different memory settings required, like in Docker plugin. So the worker executor itself, we are still in load assets task, is an injected type, so it's provided by Gradle for us. We are not interested in, we are not managing its life cycle. It's got provided for us. And this is the visual explanation of what I've been telling, that there is a idle windows where we can push those work units. So every work unit would be a network call that writes to the file. Work item identification or setup is pretty straightforward. You extend over work actions. In generic, you provide work item parameters, and work item parameters is your type that gives a contract or promise what will be fed to the work item. So we can access those parameters later on line 8. And this is a serializable type. So in the way it actually writes to the disk those parameters, so other workers from other processes can load this, pull into your work item and execute. Creating file, making network call, this is all logic that doesn't matter how you achieve it. I will skip it because that's not that much important. You can use retrofit, whatever. So in conclusion, this was the final one. Sorry, I've tried to pack a lot of, believe me, I've halved this presentation multiple times, but the main take-off for you guys today is that a variant API, your friend, you can use sources to generate resources. You create a task, you give it to the sources. Artifacts API allows you to fetch artifact. You can get access to your bundle, Android archive, merged manifest, even to the classes or resources if required. There is a predefined cardinality, single artifact, multiple artifact, or scoped artifacts. Finally, this also allows you to, through Artifacts API, to alter the contents of those artifacts as a part of the pipeline. So what we did, we modified Android Manifest, added some property within it, and married it to the Artifacts API. Make sure to use properties and providers. You may ask what could be used, and it will be best practice, setters and getters. This is a bad practice, just passing the reference to the task. Wrap your input, output, use properties from the Gradle APIs, and you will be good. And employ worker executors for parallelizing tasks, like pulling a lot of files for some reason. Our use case was downloading multiple icons for different density of screens. And finally, if you want to get in touch with me, here's the QR code. The presentation goes on the other side. And questions, if any. And I believe we probably can handle 2 questions maximum. And if you still have questions, you can speak directly to me afterwards. Then I guess we are good. Thank you.